Okay, this is the data 2 years, and then we can open the 2-year description. So first one is female or not. JC is actually the junior college. It's a 2-year credit, and then university is a 4-year credit. So log hourly wage is already take a log here. So I can find the 11th, and then what was our model? Our model is the okay. So original one is what here, JC, university, and experience. Okay. So my Y is 11th, and then yeah, 8, 9, 10. So I will find out. So 1, 2, 3, 4. Okay, this is the log wage, and then this was a experience, right? And then JC and university. This is the JC, and this is the university, right? So I don't need to change this one. So I will do the data analysis here. Okay, so regression, and I will bring up here. So my Y is the K. So I can simply choose here and shift control going down. Okay, and then X variable will be this, shift control down and move to. So since our first row is a label, so I instead the label and confidence interval, I will choose 99 here, and then yeah, and then click OK. Then you will see this one. So that's why I choose 99, because 95% is the kind of the default given. And since I type in the 99, that's why the additional one, I can get a 99 confidence interval. You can see the p-values, right? Everything is p-value is quite small, so all of these things is significant. Everything is significant. But if you take a look at JC and then university, these two numbers are pretty similar, right? So you might think, okay, the university has a higher impact on the over the JC, but can we tell statistically significantly university has a bigger, different effect on the log's wage, hourly wage, compared to the 2-year college years. So what you can do is to test that. So this is just a regression, but I want to know what would be the case. So I will JC, and then okay, I will add here, insert, and then I will create, okay, this is the total college. Okay, so this is JC plus university. Control C and shift control, not all the way down. Yeah, so I just created a formula. Just add this JC plus university. So why I'm doing this is to recall we want to find out that this null hypothesis actually beta 1 and beta 2 are actually different or not. So we switch, because we cannot do that right away, so we switch to the theta, right? So in using the theta, we can rewrite our model to the JC, and instead of just university, we use a new factor, which is a JC plus university. So if you find out that this theta 1 is the not non-zero, because this is a typical t-test, then we can say this is the we can reject the null hypothesis or not. So that's why I'm creating the new parameter, not parameter, it's a new predictor, or the independent variable, so JC plus university. So we created a JC plus university here, so I can bring the data analysis. And regression. And my selection is not now is a experience JC and total college, not the university. Oh, I have to change this one. This should be L, right? Because the this should be L, because my log wage is moved back one step, so my Y is yeah, that's why. So okay, it's a real result. So if you do the regression, now this is the correct one. Now if you take a look at it, now the coefficient of the JC has a p-value which is greater than it's about like 14%. Yeah, therefore we can say this is not significant, which means we cannot reject the null hypothesis. So which means its original form. Yeah, this is two different number, but maybe this difference is come from the sampling error. Maybe originally they are the same number. Maybe not, but we don't have enough evidence to say they are significantly different. Okay, I think the difference between here, the p-value here, and the p-value here is different because this one uses only the one side, right? But this one is that's why it has a difference. But anyway, it's the same thing. Confidence interval here for the JC. This confidence interval includes 0, and this confidence interval also includes 0. So we cannot reject the null hypothesis, which means we cannot say our first regression, these two numbers are significantly different. We cannot say that. So now this is a little different hypothesis test and the linear restriction. Linear restriction means is there any linear relationship, right? So what is the difference between the t-test and f-test? Is a t is for the comparing two numbers. Right? And then f-test is for the comparing more than 2. So t-test is usually like a beta j is 0 or not, or beta j minus beta 1 minus beta 2 is 0 or not. So basically we are comparing only the 2, but here this and this is a 2. I mean the equal sign is only happen once. this number versus this number, and this number versus this number. But F test is more than 2, so it's like A equals B and equals to C. So we have to have a more than 2 or more equal sign here. So here, if you take a look at it, the default F test, if you go to the Excel or R, right, you got a F test here, right? Significance F is 0 and this is F, and you can say this is a significant because our F is greater than the significant F. So this F test is the null hypothesis test. This F or significant F is trying to test H0 is the beta 1 equals beta 2 equals beta 3. Here we have a 1, 2, 3 here equal to 0. This is null hypothesis. So since we can reject the F, so we reject F is greater than significant F, and so we reject H0. That's a typical, but however, we can do the more than that. So this is like this. Even though we write that way, but this is a beta 3 equals beta 4 equals beta 5 equals 0. But we have a more than that, beta 1 and beta 2. Only beta 3, beta 4, beta 5. Since we have a multiple variable and then compare this multiple variable, because there is so many equals, 3 different equals, so that's why we have to use F test, not the T test. T test has only something equals something, but F test is something equals something or more, right? So since this means this one, so you have to use a F test. But typical F test you can find in the Excel or the R is the everything, not the intercept. Everything is the 0. That's the default F test. That's pretty simple. So that's why we want to have instead of the everybody. So can we just test the F3, F4? I mean the beta 3, beta 4, beta 5 equals 0 or not? So we will bring the MLB1. This is like a salary of the baseball player. How many years they played in league and average number of game per year, or the batting average, home run per year, and then run batted in per year, and so on. Okay, so